Hello, Algebra students. Welcome to Lesson 11. In this lesson, we're going to talk about another operation that you've been doing for a very, very long time. We're going to be talking about multiplication and division. And one of the things we're going to say is that all division is really multiplication. There's really just one thing about division that you have to watch out for, one rule that you can never break with division. Multiplication is a lot simpler. That's why we're going to start with multiplication. We're going to talk about some division today. But I do have to remind you that all division is actually just multiplication of a fraction, the same way that all subtraction is really just addition of an opposite. And we're going to learn about an inverse today. When we talk about multiplication, there's an inverse property of multiplication. Remember, we had an inverse property of addition. The inverse property of addition stated that if we add the opposite of a number to itself, we get 0. There's a similar sort of property with multiplication that involves fractions and multiplying numbers by a certain fraction that relates to that number. So we'll get there in just a little bit. Let's start by talking about multiplication. What is multiplication exactly? Well, just to define it, because you might have memorized a lot of multiplication tables in your day without ever actually thinking what multiplication is. It's repeated addition of the same number a specified number of times. So 6 times 3 is just 6 added to itself 3 times. 6 times 6 times 6. 6 plus 6 plus 6. Okay, now I got a little bit confused there because previously we talked about exponents. Exponents, remember, were repeated multiplication. So if I had 6 to the third, that would be 6 times 6 times 6. But when I have 6 times 3, 6 times a number is just repeated addition. Plus 6, 6 plus 6 plus 6. Okay, so don't get confused between those two like I just did as I spoke it. But whenever I do the operation, I can always get it right. It's just we talked about something similar to this not that long ago, and I want you to make sure you're keeping those two things straight in your head. Another property of multiplication is that it doesn't matter the order that you do multiplication. We'll talk about that later. But 6 plus 6 plus 6, 6 plus itself 3 times, is actually equivalent to 3 plus itself 6 times. These would be the exact same sum. And when I add these all up, I find that I get 18. So 6 times 3, the purest way to write this is 6 plus 6 plus 6, or 6 added to itself 3 times. But it could also be 3 added to itself 6 times, and you'll get the same thing. All right, now let's talk about some properties of multiplication. And we're going to call these properties of real numbers because these actually apply to all real numbers. Rational, irrational, whether they're integers or counting numbers or whole numbers, it doesn't matter. These are going to be properties that apply to all real numbers. One of these properties is going to be the multiplication property of -1. For every real number a, if I multiply that number times -1, or I multiply in the opposite order, -1 times that number, I get the opposite of that number. Multiplying by -1 gives me the opposite of that number. See the example, 9 times -1 is the opposite of 9. Same with -1 times 9. We can flip them around and they do the same thing. I can't stress enough how important it is in working problems like this that you're going to start working in this lesson. You've got to keep your negatives straight. You've got to write out your problems meticulously, and you have to keep your negatives straight. I'm going to tell you that probably about half the class isn't going to heed my advice, and you're going to struggle for several problem sets. I'm hoping that's not true, but if history tells me what's going to happen, I'm going to have about half of the class ignore the advice to be careful about your negative signs. You're going to try to jump ahead and just solve problems without working things out meticulously, and things are going to be made positive that shouldn't, or be made negative that shouldn't, because you're not keeping track of this property. How if you multiply anything by -1, you get the opposite of that thing. It's also a zero property of multiplication. This one no one will ever mess up because it's so simple. If you multiply something by 0, you get 0. Doesn't matter what it is. 9 times 0, pi times 0, the square root of 2 times 0, 3 plus 7 minus 8 in parentheses times 0. You're going to end up with 0 at the end. That's the multiplication property of 0. And then lastly, the inverse property of multiplication. This is the one I was talking about earlier. for every real number a as long as a is not equal to 0. We'll talk about that in just a second. Why can't a equal 0? Well, if you multiply the number a times the inverse, the multiplicative inverse, to get a multiplicative inverse, you take a number, and so let's just say a is equal to 3, like down here. 3 is the same as 3 over 1, right? If you divide 3 by 1, you still have 3. Any number, like that's a whole number, I suppose a counting number is probably a better thing to say, is really that number divided by 1. To get the inverse property, or to apply the inverse property and find the inverse of that number, I simply flip the numerator and denominator. So the inverse of a is 1 over a. The inverse of 3 is 1 over 3. The inverse of 5 is 1 over 5. Now here's where this becomes useful when we're dealing with fractions. The inverse of 1/3 is 3 over 1. The inverse of 2/3 is 3 over 2. To find the inverse, I just flip the numerator and the denominator. And any number, doesn't matter what kind of number it is. It could be irrational number. It could be the square root of 2 times 1 over the square root of 2. Anytime I multiply a number times its inverse, I get 1. Or an inverse times its number. It doesn't matter which order I multiply in. Okay? So there's 3 properties of real numbers you need to remember. These are multiplication properties, really. Multiplication property of -1, multiplication property of 0, inverse property of multiplication. Now, what happens if we're multiplying numbers and we have negative numbers involved? Well, there are some rules that you should follow. When you multiply signed numbers, the product of 2 numbers that have the same sign are always positive. Doesn't matter if it's 2 positives, which is what we're used to dealing with, or 2 negatives. 2 wrongs make a right in this case. -5 times -3 equals positive 15. How did we know that? They have the same sign and we're multiplying them. However, anytime we multiply 2 numbers with opposite signs, doesn't matter the order, if they have opposite signs, then what's going to happen is they're going to multiply to make the opposite of a number, a negative number. Okay, they're going to make a negative number. So -2 times 4, one's positive, one's negative, -8. 6 times -2, one's positive, one's negative, -12. I just do the multiplication and I put the negative in front. With division, things are very much the same, except for one tricky thing related to division. That goes back to this inverse property we're going to talk about in a second. The quotient of 2 numbers with the same sign is a positive number. 6 divided by 3 is 2. 6 and 2 are both positive. My answer is positive. -8 divided by -2 is 4. Okay? Both numbers were negative. That means that their quotient is positive. Hey, let's pause for a second. I just want to point out that there are different ways to show multiplication and division, since we've seen a few of these examples already. So notice up here I have this little dot symbol, a dot -1. That little dot symbol means times. But I can also show multiplication by just putting 2 numbers next to each other in parentheses like this. 3 and 4 are next to each other in parentheses. Even if one number is in parentheses, if this 4 was in parentheses and this 3 was next to it out front, multiplication is shown by just putting numbers next to each other. So 3 times 4 can be shown this way, or it could be shown 3.4, and then sometimes you have it this way that I have up here. Although I included this, the book didn't include this because this one's kind of falling out of favor as you get further and further along in algebra. So you don't really see the X times symbol used anymore in algebra. It's going to be this dot symbol or just numbers right next to each other like this. This means 3 times 4 when you see numbers in parentheses right next to each other. Division is shown with the division symbol, but honestly, this symbol falls out of favor in algebra. We don't see this very often, only in a lot of contrived problems. Usually we see division shown as fractions. 6 over 3 is the same thing as 6 divided by 3. The implied division is built into the fraction symbol. So it's not like we're using the fraction symbol a different way than we use it when we write fractions. Fractions were always division problems. Did you know that? Anytime you've ever seen a fraction, it's actually just a division problem waiting to happen. Okay, so these are the 2 ways that we show division. Let's take a look at another example, the last rule for dividing signed numbers. So if we divide two numbers with the same sign, it's positive. If we divide two numbers with different signs, it's negative. Notice it's shown both ways here. 10 divided by negative 5 is negative 2, or 10 divided by negative 5 is negative 2. Negative 12 divided by 3, doesn't matter the order. One's positive, one's negative. We're going to have a negative answer, negative 4. All right, we're going to take a look at some practice problems so we can practice working with multiplying, but I think you're going to find that this is easy. The hardest parts of this are finding the inverse of a number, okay, keeping track of your negatives, but that's going to be a constant problem throughout the year that you're just going to have to pay attention to and get good at. And then also you have to remember that if you multiply two different sign numbers, you have a negative. The other one's easy. It's always easy to find the positive numbers, but for some reason, students tend to mix up the negatives. All right, let's get looking at a practice set to see what this is all about.